Hey guys, good evening, all of you.
Hello, good evening. Good evening.
Hey, good evening, Gary.
Good evening, Law.
Hey, good evening, Gary. So, guys, in the last classes, we have done with the concept of the CST protocol, and we also have done with the PVST, right? And we have also seen the PVST load balancing mechanism, right? And also, we have seen that how the TCN BPD is working, right? Like we have three types of topology change. We have an insignificant topology change, we have a direct topology change, and we have an indirect topology change. And we have covered the uplink fast features. Then we have covered the backbone fast feature, and then we have covered the port fast feature, right? Now, guys, do you know why we have used this feature uplink fast, backbone fast, and port fast features to just improve the PVST performance, or we can say that to make our PVST faster. To make a PVST faster, we used this feature, right? So that in this case, what happens if you're going to enable the port fast? So access port immediately comes in the forwarding state, right? Comes in the forwarding state. If I talk about the uplink fast, in this uplink fast, what happens if you're going to apply the uplink fast feature? Then if you have a direct link failure, right? Immediately forwarding state. And if you have a indirect link failure, then it took the it take the 30 seconds to put the port into forwarding state, right? These were the features that we are using to make our PVST fast. And I'm not telling you this is the bad, right? But guys, try to understand. Still what? Still we have a 30-second over there in the backbone fast. But do you know one thing about the port fast, uplink fast, and backbone? The common thing about this person, if you see the common thing, बिट्टू मेरा कॉल है क्या? हाँ बोलो. या अगर तुम ग्रुप डिफरेंट कर दोगे तो तो आप कॉस्ट बढ़े. हाँ ग्रुप डिफरेंट कर दो, हो जाएगा. VR or VS, we can do that. Yep. Sure. Okay. All good. So now if you guys have a look, if you read this line, the Cisco Enhanced 80.1D, that is talking about the PVST protocol, a specification with the features such as uplink fast, backbone fast, and the port fast to speed up the convergence time of a bridge network. To make a PVST fast, to make a PVST faster, we used, right? We use the uplink fast, backbone fast, and the port fast feature. But the drawback of this person, right? What is the drawback? The drawback is that this mechanism are proprietary and need a additional configuration. It means that these are the proprietary that we are using the uplink fast and port fast. These are the maximum things are, you know, the Cisco proprietary. Maximum things. This part of the Cisco proprietary, right? What about the different vendor now? And again, to make a PVST faster, right? understand the concept now. To make a PBST faster, right? We need to put the additional configuration. And forget the additional configuration. You need to find which one should be a direct link failure and which one should be an indirect link failure, right? You need to find, okay, so where should I apply the uplink? Where should I apply the uplink fast feature, and where should I apply the backward fast feature, right? You need to put the additional configuration, and you need to take care about, like, which switch, right, is the access layer switches and which switch is the distribution layer switch, because the recommendation of the uplink fast is what you always need to configure this guy at the access layer switches, right? And again, at the last, what happened? Additional configuration. Next point, it is the Cisco provided. These all are the Cisco providing. What about the different vendor now? How we can make it faster? Take example. Okay, if you have a switch over there, right, and we have a one router on this side, and one we have router on this side, and one we have router on this side, and one we have router on this side. Take example, right? This is router number one, router number two, router number three, router number four, and this is the switch. On this switch, by default, what I'm running over there, I'm running with the PVST, right? Now tell me one thing: how much time this interface will require? How much time this interface will require? And how much time this interface will require? And how much time this interface will? 30 seconds. What is the EHRP hello time is there? The EHRP hello time is a 5 second, and EHRP hold on time is a 15 second, right? Take example, if your link get flap, right? Take example, if this link get flap, what happened? Your EHRP will becomes up within a second, but the PVST will take the 30 seconds to make this interface in the forwarding state. If just link flap will happen on this particular interface, take example, if the link get flap, okay, if the link get flap, what happened? Your EHRP will comes up, right? Because EHRP is faster, but this interface still go through the listening state and then learning state. 30 seconds. So can we say that your routing is faster? Switching. And nowadays, guys, we have a mechanism, something called as a BFD, right? By using the BFD, right, you know what happened? We make a much faster, much faster in the sense of it's talk about the millisecond. It was dealing with the second, right? Previously, it was dealing with the second. Now, with the help of BFD, right, we can deal with the millisecond. So now see how the routing is faster as compared to the switching order. To avoid all this problem, what we have introduced the concept of the RSTP protocol, or we can say the RPBST. RSTP is the IEEE standard, RPBST is a Cisco providing. And what RSTP allow? It's allow the rapid spanning tree protocol. Rapid means what? It is a faster. Rapid means what? It's a faster. It means that now your spanning tree interface, right? Now your spanning tree convergence will happen. Now your spanning tree convergence will happen within a second. So do I need to wait for the listening state? Do I wait for the learning state? No, we don't need to wait for this guy. And how this thing will happen? We have just introduced the new type of BPD over there. And that BPD is called as a BPD version 2. If you see one thing over there, let me show you this part. Wow. Meanwhile, I'll just write on something more because it takes some time to boot up the other devices. If I talk about the difference between the PVST and RSTP protocol, right? Take this one as well as how the RSTP is much faster than the PVST. In PVST protocol, what happened? We have a blocking state, first disable, blocking, listening, learning, and forwarding. If I talk about the RSTP protocol, in RSTP, what happened? We just have a discarding, learning, and so all these three state, right, is going to combine into the single in the RSTP protocol. Learning will be learning and forwarding will be forwarding. Learning is still learning and forwarding is still forwarding. See, if you think about it as an operational point of view, right? As a operational point of view, what is the use of? Think about it. Think about it. What is the use of disable state? Nothing. Am I sending any kind of data traffic? No. In a disable state, I talk about the disable, no data, no MAC learning. In a blocking, same thing. In listening, same thing. So what is the use of this three state? Nothing. Okay, the port selection, right? That's it, no? The only the port selection, that's it. So what is the use of the common thing, right? The common thing is this guy. No use, right? Nothing. Think operational. I'm talking the operational point of view in the sense of what, right? The the way of packet forwarding. Nothing we are doing, not the data learn, no data, no MAC learn. So I will convert this three state into the single one that is called as a discarding state. In the learning still I'm going to learn the MAC address, right? In the forwarding, I'm going to forward the packet. If I talk about the another difference between the RS PVST and RST protocol, PVST, we have something called as a port roles, right? What are the port roles we have? Root port, designated port, and blocking port, right? In the case of RST protocol, we have still have the same one. Only the thing is that I'm going to add the one more port over there and call as a backup port. Backup port only comes in the picture whenever you have a hub in the network, a half duplex device. If you have a look, Cisco packet switcher, These are the things that is going to make our RST faster, right? So I'll take a switch over there, and I'll take some hub. Let me find the hub. Is this guy is a hub? I think so. Yes. And I'll connect this guy and this guy as well as. And if you see, I'm going to enable the RST protocol. It's fine mode rapid PVST, right? RPVST on Cisco devices. And so it's fine tree. You can see that backup. State is blocking still, right? And one more thing, you will not see the discarding state. You will not see the discarding state. You will only see the blocking state. Lower receiving. It's been 1 minute. All done. So you backup port is only comes in the picture whenever you have a half duplex. Otherwise, the election of the port, right? The election of the root bridge is same. Nothing is different. Right now, if I compare with the BPDU, right, that's the most important part. Let me go to the switch one, and I'll configure this guy enable. Host name will be switch one, and switch two now enable configure enable host name switch three. Spanning tree mode PVST. If you see now the spanning tree protocol, we have a BPDU flag, and let me capture this link. Not a screenshot. Take this screenshot of this guy. Then I'll show you each and everything. No, this time screenshot is not working sometimes. And here we have. If you see, this is the BPDU, right? This is the PVST, right? At the same time, I'll show you the rapid PVST as well as it's binary move rapid PVST. And now see the link now capture and hold on. Then you can have a look the difference. Can you see the difference between this guy and this guy? The BP2 version, I'm going to use the 2, and this protocol is a RST. BP2 type is what? It's a rapid, and the same more like a multiple spank as MST as well. The most important part, if you see the size of flag, right? The size of flag is a 8-bit. The size of flag is a 8-bit. In a PVST protocol, how many flag I'm going to use? In the PVST, I'm just going to use the 2-bit of flag, right? The 6-bit is reserved. That is for the unused. In the case of, if you just have a look this part now, this guy is going to make a PVST faster. Sorry, rapid PVST is faster. This is just going to use a 2-bit of flag, right? The rest of the 6-bit is unused. In the case of BP2 flag over there, the 8-bit, right? This 8-bit, I'll completely going to use the all 8-bit over there. And each have a different meanings over there. This port role is going to use for the 2-bit, right? This is going to use for the 2-bit now. 2-bit how? We have 4 values in the 2-bit. We call as 0, 0, 0, 1, 1, 0, and 1, 1. 0, 0 is going to represent that it's a blocking. It's going to represent that, no, 1 minute. This should be listening, learning. No, root port designated for alternate backup. I think this is the DP. This should be a RP, and this should be something. Let me check it. This is unknown. This is the result. This should be a backup. Alternate blocking port, and this is result. So total, we have all this 8-bit I'm going to use in the rapid PST protocol, and each one has a different. Can you see that this 2 1 is same, right? To position, acknowledge, and TC is same like this guy. Only the thing is that we have a new flag is agreement, forwarding, learning, the port roles, and proposal. And the most important is this 2 1. This 2 1 is going to make a agreement and proposal. This 2 1 is going to make a rapid PSTs faster. The proposal and agreement. The complete rapid spanning tree protocol is going to depend on this two flag, proposal and agreement. And this is the guy that is going to make a fast over there. If you have a look, if you see from an operational point of view, right, there's no difference between the port in the blocking state and the port in the listening state, because both this guard the frames and do not learn the MAC address. So there is no sense, right? There's no sense in a RST protocol to define the each one is a separate state. We are going to combine all these 3 states into the single one that's called as a discarding, discarding, discarding. Learning will be still learning, and forwarding will be still forwarding. And why we have introduced the RST protocol? The reason is to introduce the RST protocol because this feature, right? Whatever the features we have to make a PVST faster, the uplink fast, backbone fast, and port fast is the proprietary, right? And need additional configuration. So that's why we introduced the concept of RSTP protocol to make a spanning tree or to make a layer 2 faster, because my layer 3 is faster, right? To make a layer 2 faster, we introduce the rapid PST protocol. And what rapid PST is going to do over there? It is going to make a convergence within a second over there. So how this thing will be work over there? Try to understand what happened. For example, this is the one switch over there. switch 1 and switch 2, right? Switch 1, switch 2. This interface we have a 0/0. This interface we have a 0/0. Now we have a this guy. So MAC address will be A and priority 32768, right? The MAC address will be priority 32768, right? Now, right now, understand this part. This link is down. Okay, this link is down. Once this link comes up, what happened? This guy is going to send the BPDU, and this guy also going to send the BPDU. Or in this BPDU, what happened? Both this person is going to assume that, hey, first it will send the own bridge ID information. I'm just going to say the A plus 32768. Okay, I'm not going to send the priority. I'm just going to send the MAC address because I don't have much space, right? Understand this part. So I'm going to send the MAC address will be A now, and he's going to send the MAC address B. And at the same time, what this guy is going to assume that, hey, I'm the root bridge. Why? Because I'm announcing with the proposal bit. Which bit? Proposal. I'm proposing, right? I'm proposing, hey, I'm a root bridge. So he will say the, hey, I'm the root bridge and I'm the root bridge. Once I'm going to say the root bridge, what happened? I'm going to make this interface as a DP and TP. This is the first time behavior. Whenever this link is down, when this link comes up, automatically what happened? Both this guy is going to send the proposal, and in the proposal, what happened? He's going to tell this person, hey, my this interface is designated and this interface is done. This flag I'm talking about, this proposal flag will be on. Right? Both this guy is going to send the proposal and proposal, right? Once the switch to listen to me now. Once the switch to will receive this information on this particular interface 0/0, what switch to will do? It will compare, right? It will compare this bridge ID information and this bridge ID own information, right? And what switch to will identify? Hey, the switch one has a lower one MAC address, right? What this guy will assume that switch one has a lower one MAC address, and it will send the this person, hey, agreement flag. Which flag? Agreement. This now. By telling this person, hey, this guy is saying that, hey, you already have a lower MAC address, right? A as compared to me is a B. So you have a lower one. I'm setting the agreement. It means that you are the root bridge. And immediately what happened? I'm going to change this port role and I'm going to make this guy as a RP because I have a lower one. So at the first, what happened when this link goes, when this link is down right now, both this guy, when this link comes up, take example, when this link comes up, what happened? Both this guy is going to assume that, hey, I'm the root bridge and I'm the root bridge. And they will make this port into a DPY by sending a proposal bit. Once the switch 2 will receive the BPDU from the switch 1, switch 2 will identify switch 1 has a lower bridge ID. And what happened? He's going to tell this person, hey, by sending the agreement, my port is a DP. Sorry, my port is a RP, and I'm not a root bridge. And all this process, this is called as a three-way handshake. All this process will complete it within a second. All this process will complete within a second. So within a second, what happened? All the port role selection will be happen. We don't need to wait for the 30-second listening and learning state. We don't need to wait for the listening and learning state. But take example, what happened? The same example. Take example on this one, same one. What happened if this guy is going to send the proposal? Listen to me. If this guy is going to send the proposal, right? By telling this person, hey, my this interface is the DP and I'm the root bridge. What happened if I'm not getting the any proposal or any agreement from the neighbor switches? What happened if I'm not getting the any proposal or not any agreement from my neighbor switches? Because my neighbor switches is running with the PBST protocol. Will they understand the any proposal? Do you see? Have you looked at this one flag? Are they able to understand the any proposal? The PBST one? No. PBST does not have any kind of proposal and agreement, right? So they will not understand. So if they will not understand what happened, this interface still we go through the listening state, learning state, and then forwarding state. What about this guy now? If the switch one will not receive any kind of proposal or agreement from the neighbor of the switches, what switch one will do? This interface will slowly move, or we can say this, yeah, this interface will slowly move in PBST. It means that now this interface will go through the listening state, learning state, and forwarding. The listening that you can compare like this one, according to the RST protocol, it will be have a discarding state, right? So it will stay in the 15 second in the discarding state, 15 second in the learning state, and the forwarding state in the 30 second. So on this segment, right? On this segment, the LXM will be happen in 30 seconds. So we can see that the PBST protocol is a backward compatible. Sorry, RPBST is backward compatible with PBST as well as. And this is the reason, right? This is the reason why do we have a learning state over there. Otherwise, no need of learning state, right? Think about it. Do we need a learning state over there? हमें समय आपको हमें समय आपको कॉल करो बैच नहीं करके कॉल करो हेलो 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 yes 1 minute. So RPST is a backward compatible with the PVST protocol. So if the RSTP, right, switches does not receive any kind of BP2, right, the RSTP BP2 from my neighbor switches, so slowly it will move in the PVST state. So it will go for the discarding the 15 second, then learning in the 15 second, and then after that we have a 30 second. So on this particular segment, right, on this particular segment, the election will happen in the 30 second, or we can say that the data traffic will start after 30 second. If both the switches is a participant in the RST protocol, right? In that case, what happened? This will require the only within a second the convergence will happen, and within a second, what happened? All the root bridge election and the root port and DP port election will be happen within a second. But what happened if you have a right now we just have a two switches? Take example if you have multiple switches over there. So I'll do one thing. Let's take example. I don't have space. So let's do that over there. And now understanding this part now. Switch one, right? Switch two, and switch three, right? And we have a like this. Switch one, switch two, and switch three. This interface we have 0/0. This interface we have 0/0. This interface we have 0/1. This interface we have 0/0, right? And we have a MAC address will be, I'm not going to write the priority, MAC address C, right? Understand what happened if this guy will send the proposal, right? If this guy will send the proposal, once this interface, right, will be up. Right now both the interfaces down. Take example, both the interfaces down, right? Once the interface comes up, right, any of the one segment, right, any of the switches will going to send the proposal. So if this guy will send the proposal, so what happened once the proposal will receive on this particular interface, right? So he will also send the proposal. Meanwhile, what happened? What switch 2 will do? Switch 2 will put this interface right into the discarding state. Why? To just avoid the loop. How? Take example. If this guy is going to also make, if the simultaneously, right? If the simultaneously the election will happen, what happened? Maybe this guy also becomes RP, and maybe this guy also becomes RP. So what happened? Is it possible on a non-root bridge we have two RP? No, it's not possible, because non-root we will have a single RP, right? So in that case, what happened? So if the one segment election is going on, right? If the one segment election is going on, so another segment will move in the discarding. Doesn't matter how many segment we have. All the segment will move in the discarding state. All the segment, right? Only on the non-edge port. Non-edge port means what? A port that is connected with the switches and router. Not the access, not the edge port. Edge port in the sense of, for example, this is the PC. This PC will not move in this interface, right? 0/3. This is the interface that we have a PC connected over there. This is the edge port. This edge port will not move in the discarding state. Only on the non-edge port, because the RSTP is going to make an election on the non-edge port. So all the non-edge port, right, will move in the discarding state. So take example, if this guy's in the, hey, this is the proposal over there, and this is also proposal. What switch to be identify? Switch one has a lower MAC address. It will send the agreement. Hey, you have a lower one. So this guy will be in the DP, and this guy will be in the RP over there. Now, what happened? Now this interface, right? Once the election has done over there, now this interface will be start the election. Now this guy will send the, hey, proposal and proposal. What switch 2 will what switch 3 will identify? Okay, the switch 2 has a lower MAC address, so it will send the agreement over there. Proposal, and it will send the agreement, because switch 2 has a lower one. So this guy is in DP, and again this guy is in the RP. So this is how all the election will be done, and this all the selection, right? Once they have done with this segment, it will go for this one, and so on. So all this segment will be happen within a second. So we don't need to wait for the 30 seconds that we have normally we do in the listening and learning state. So if you have a look over there, let me show you this part. So switch one, come on, switch two, host name, switch two, or as the spine tree mode, rapid VST, spine tree mode, rapid VST.
Hello, can you go to one paint file once? So here, first the election between switch 1 and switch 2 happened, right?
Yes.
So what and after that the election between switch 2 and switch 3 happened,
It's
right?
not like happen between the switch 1 and switch 2, first of all, right? If the first, like take example, if this interface get up first of all, right?
Yes.
Okay, So the election will happen over there. For taking example, if this interface gets first of all over there, then election will happen over there, then election will happen over there.
Okay. In this case, if the first that switch to and switch to interface came up, the switch to will be the root bridge, right?
Yeah, so S2 will be the root bridge. So take example. Oh, let's do one thing now. I'll make this guy as a priority 0. Okay.
Okay.
And this is the 32768, and this is the 32768. And right now this interface is down, and this interface is down, right?
Okay.
Perfect. So now understand this interface. This interface comes up, right? This guy.
Yes.
So once this guy comes up, what happened? This guy will send the proposal, and this guy also send the proposal, right?
Yes.
And after the switch 2 will identify the switch 1 has a lower MAC address, so it will send the agreement over there. So this is the DP and this is the RP, right?
Yes.
Okay. Now let's come to this part now. Once the switch 2 will send the proposal, this guy, and it will also send the proposal, right? If this comes up
Yes.
in the proposal, what happened? If you see this guy also sending the which, what happened? The priority,
0.
right? So this guy, the what priority is sending over there? 0, right?
Yes.
Once this interface switch to, right? If this interface will receive the this is the superior VPD, right?
Yes.
The best
Yes.
VPD. Once this interface will receive the superior VPD, what happened? It will make all this interface into the discarding state now.
Okay. Okay.
Okay, and make this election over there. So what happened? This guy will become the DP now, and this guy will be the RP. And once they have done with this election, now again they will start the election over there.
Okay.
Understand? Now this guy will
Yeah.
make a DP and RP. Clear?
Okay.
It's depend on the superior VPD.
Okay. Okay. So once the superior BPD comes, it will give all the segments in discarding state.
Yeah, and make a re-election over there.
Either prior it have though prior it having root pitch, still it will go for the election, right?
Of course, now because you cannot have a two root which.
Yes.
I need to tell this person, hey, my dad is the other one.
And one more,
Yeah.
suppose as you said, switch 1 and switch 2 are running with RSTP,
Mhm.
and switch 2 is running with PVST. So
That
what
I'm
happens?
coming to the point. 1 minute. I'm coming to that one. Let me cover this part. Then I'm coming to the practical.
Fine, fine, fine.
So now if you see, I'm just going to enable some debug over there. So debug is find tree events and debug is find, come on, debug is find such a state, right? Do show history and oh, come on, let me do one thing. So I can do brief. So I'll do one thing. Already this interface is now no issue, right? So right, done. This is fine. So just perfect. Interface gig 0/0 shut down. So right on this interface is down right now. Okay. No shut. I've enabled the RSTV, right? Take vanilla. Windows is my fee. RSTP is there, right? Yeah. Windows go running or Windows is my fee. RSTP, why this guy is not showing the proposal and agreement. Okay, let me show you the VMware because sometimes this guy is not giving the proper output. Meanwhile, कुछ पढ़ लो और. Okay. कुछ तो तुझ से बता, कुछ तो तुझ से बता. These two port roles in the correspond to the blocking state. One is a block port and one is a backup port. Alternate port and backup port. Backup port is only comes in the picture of whenever you have a hub.
So if there is no hub, there is no concept of backup.
No, of course, there is no cause of backup. So these are the fields that we have a zero. The bit number 0 is going to represent topology change, and topology change acknowledge, right? The 7 number bit. The bit number 1 is a proposal. The bit number is proposal, and the bit number 2 and 3 is going to represent that a port roles. That's a this one, and the fourth is a learning. So this, let me show you over there. This guy. This guy should be bit number 1, not this topology. This is bit number 1 topology. Sorry, bit number 0. This should be bit number 1. This should be a bit number 2 and 3, right? So I'll just mention 2 and 3. This will be bit number 4. This will be bit number 5. This will be bit number 6, 7. Right? That is going to make a PVC. This is the BPD version 2, right? And here we have bit 0 is less significant bit, right? Less significant is starting bit. Starting bit. Most significant is ending bit. And the RST BPD is going to be used the BPD version 2, right? BPD sent are every hello time, that is a 2 second, right? Not simply greater than even. All done. Perfect. So here we have. Okay. All good. And here we have switch one. One. Pick up. Pick up. Take some time. Leave it. Now, read this line. Faster aging of information. In PBST protocol, what is the max time over there? 20 seconds. In RSTP, your hello time, or we can say the no, not hello time, your max time is going to behave like a hold on time. How? On a given port, if the hello are not received 3 consecutive times, right? It means that 2 into 3, 6. The protocol information can be immediately aged out. Now we can say that the BPDU are now used as a keep alive mechanism between the bridges over there, right? बोले कि okay. So now if you see that the BPD are now used as a key collab mechanism between the breaches, right? It means that you are like if you remember that in the EHRP how the hello and hold on time is working. In EHRP, what happened if we have a EHRP negotiation between R1 and R2, and if this guy is going to extend the hello packet in the by default 5 second, right? Is it? Now what happened if the router 1 is not going to send any hello packet? Router 2 will wait for the 15 second, right? And after that, router 2 will declare, hey, my neighbor is dead. Same like in the switches now we have what happened in the RST protocol is going to behave like a keep alive. So if this guy is going to exchange the BPDU at every 2 seconds, fine. Somehow, if the switch 2 is not able to receive, right? If the switch 2 is not able to receive any BPDU from the switch 1, what happened? What switch 2 is going to do? It is not going to wait for the 20 second, right? Normally it is happen in the PVST protocol. It is not going to wait for the 20 second. It is just going to wait for the 3 hello miss. That is called as a 6 second, right? After 6 second, what happened? I'm going to declare my neighbor is dead, right? And in that case, what happened? I'm just going to say, hey, now a bridge consider that it lose the connectivity to its direct neighbor root or doesn't matter what port are there, right? And if it is misses the 3 VPD in the row, this fast aging of information allow the quick failure detection, right? So do I need to wait for the 20 second over there? No, I don't need to wait for the 20 second. I can quickly determine my neighbor is dead, and I can what happened? I'm going to fast age out all the MAC address from that particular interface, right? This is the another one that is going to make your PVST, sorry, rapid PVSTs fast. Normally in the PVST protocol, what happened? We need to wait for the 20 second. Now we don't need to wait for the 20 second. We just wait for the 6 second. Have a look. Let's come back to this guy now. If you see enable, and I have switch 2 as well as enable. Let me do one thing. First of all, do show spine tree. Let me check what protocol I'm running over there. It's a RSTP, so do show IP interface brief. I think so my all interface is done perfect. So I'll shut down this particular link over there right now. Okay, I'll just shut down this particular link. Interface E0/0 shut down. Yes, and switch one as well as interface E0/0 shut down. Done. I'm going to enable the debug spine tree events and debug spine tree switch state. Show history, and I'm going to call this guy on a switch 2 as well as. Now see the proposal and agreement between this guy and this guy. Interface is 0/0, no shut, and interface is 0/0, no shut. This one and this one. See, now let me stop this guy. Do you all, and do you all. Can you see that? Once this interface comes up, right? Switch one. What this switch one is going to enable the RST protocol over there. By default, RSTP is enabled over there, and initializing the port Ethernet 0/0. I'm going to move this port into the blocking state. That is called as a discarding state according to the RST protocol. And now what this guy is going to tell this person, hey, my this interface is a DP. So I'm behave like a root bridge. And I'm sending the proposal from this particular interface, right? What this guy is telling you, the switch to now. Initializing the port, once I put the no shutdown over there, initializing the port in the RST protocol, move the port in the blocking state just for the few milliseconds, just checking that is there any loop or not. And now I'm also going to tell this person, hey, you are also designated. Is it possible? At the same time, both will be designated. I'm also being a root bridge, not possible. And I'm going to transmit my proposal. So both are sending the proposal and proposal. After that, what? Once the switch 2 will receive the proposal from the switch 1, what this guy is telling you, hey, RSTP, update the roles. I need to change my roles because I received the superior BPDU on the particular interface in 0/0. So once I'm going to receive the superior BPDU, what I'm going to do, I'm going to make this interface as a root port, and I'm going to send the agreement flag. Hey, I'm done. How much time it will take over there? Can you see that this guy is going to represent that it's R, right? This guy is going to represent a second, and not this is the R, this is the minute, and this guy is going to represent a second, and this is the millisecond. How much time it is? No shutdown. 298, right? 298, 300 near around 302. We have a 64. Near around, we will take the 700 millisecond. Near around, it take the 700 millisecond to make a election of the all the ports and put the port into the forwarding stream. We don't need to wait. So now tell me, if the EIGRP flap will happen in your switch network, and if your RSTP is enabled, no need to wait for the 30-second, right? Immediately my switch RSTP protocol take a convergence over there as compared to the EIGRP. Now the RSTP is faster, right? All good. Now understand in this case what happened. Have a look over there. And I'm going to enable this guy interface is 0/1 shutdown. I'm going to make it this guy as a shutdown right now, this interface. And switch 3, right? That this guy. I'm going to also enable the interface E0/1 shutdown and interface E0/0 shutdown. So both interfaces down now. And a spine T mode PVST now. PVST. So this guy is right now, this interface is down, this interface is down and running with the PVST protocol. And this guy is running with the RSTP protocol. Have a look. Debug spine tree events. Debug spine tree switch state. All good. Switch 3. Switch 2. And I have a debug spine tree switch state and debug spine tree events. Perfect. All clear. Now close loop. If you see Right now, this guy is running with the previous state. This guy is running with RSTP, right? I'll say the interface is 0/1, no sut. At the same time, this guy 0/1, no sut. What happened? This guy is sending the proposal, and I'm going to make this interface designated, right? I'm going to make this guy's direction over there. Listing this guy. Wait for some more time over there. It will also go through the listing. It will go through the learning. Can you see? Awesome. Which interface? 0/1. Because I don't have a listening state, right? I don't have a listening state. Till this time, what happened? I'm going to send the proposal called as a discarding, right? And then now learning to the forwarding. So this guy, it has sending the RSTP BPDO, right? I'm not getting any agreement from the neighbor switches. So what I'm going to do, slowly I will make this interface first of all in the learning state, and then after 15 seconds forwarding state. How long it will take to make this interface up? 49 to 19, 30 seconds. Is it possible in the RSTP? No. Within a 1 second it was done, right? Previously, if you have a look at the output, switch one. If you see the previous output, what happened? Within a millisecond, right? It was coming in the millisecond. It's coming in the forwarding state. But in the case of PBST, if you are going to enable over there, it will take the 30 seconds. That's why we are going to call this guys we have this state over the learning state, backward compatible. Vinay, clear?
Yes, no, fine.
Perfect.
So after this, the switch one will also be moving to the PVST, right?
Yeah, this is guys behave like a PBST on this segment over there, but
Oh,
not on this segment, not on this segment. If you see on the switch 2, it's still running with the which protocol? So it's fine free RSTP.
okay.
So on this particular segment, we are running with the RSTP, right?
Yes, yes.
And this segment I'm going to run the,
PVST.
if you have a look, I'll do one thing. Can you see that my neighbor's Ethernet 0/0 is running the
Oh,
STP,
yes, PST.
right? If you see interface Ethernet 0/0 shut down, and make
So
let me 1 minute, 1 minute. Debug spine tree events, debug spine tree switch state, row history. Switch one. You can see. Do you all which interface I have done? Yes, right. Do you all? You can see that I shut down this particular link, right? On this segment, we are running the RSTP, right? See, good. Within a second.
so only that particular segment will be moving to PVST, right?
Of course, right now, because spine tree is running on the interface basis, right? For VLAN basis, not the complete entire switch over there. If you see, my this is 3 now. This is 3, right?
Yes.
This is spine tree. It's running with the IEEE PVST, right? And the
Yes.
switch 2 now. My neighbor is
RST.
born. My neighbor is born with a E0/1, right? So to saying that my neighbor E0/1 is bound with the previous neighbor. Clear?
Okay. So once the interface of E0/0 on switch 3 comes up, then the switch 1 will also go moving to the PVST, right?
Switch 1 is running with RCP protocol.
Because this interface on E0 interface on switch 3 is in shutdown, right?
This one you're talking
Yes.
about, yeah, this one.
E0/0.
E0/0 right now is also running with the PVST over there right now.
Yes.
So this guy is also running with the PVST on the segment.
Okay. 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 So okay, the interface between switch 1 and switch 2 will be in the RST.
Yes.
Fine.
Or if both interface in RSTP, then there is no point of learning state, right?
Right now, yes, of course.
Okay.
So again, can you come back again? What you say?
No, if both are RSTP, then it won't go to learning state.
Yes, right. Both are the right now. Both are in the RSTP, right? It's not
Yeah,
a both are not in the PV. Both are in the RSTP. What happened? He has sent the proposal to this guy, but he didn't get any kind of proposal and agreement.
yeah.
So what happened? What system will understand? Hey, my neighbor is running with the PVST, so it will slowly make this interface into the PVST.
Okay.
Understood?
Yeah.
Right now, I haven't configured the PVST on this interface. No, the complete switch is running with the RSTP, right? He has sent a proposal to this guy, and the system didn't get any kind of acknowledge from the sys3. What system will understand? My neighbor is running with the PVST, so it will bound this interface with the PVST. It will bound the interface with the PVST. Yeah. देखो सिंपल सा हो गया, मैंने इसको प्रपोजल दिया, ठीक है, स्विच 1 ने स्विच 2 को प्रपोजल दिया, स्विच 2 से प्रपोजल आया नहीं, तो स्विच 1 क्या एज्यूम करेगा कि स्विच 2 पीवीएसटी से चल रहा है। अगर यहाँ से प्रपोजल आ गया तो इलेक्शन हो जाएगा, देन इट विल परफॉर्म द इलेक्शन अकॉर्डिंग टू द आरएसटीपी। बट अगर स्विच 1 का प्रपोजल नहीं मिला स्विच 2 से और ना ही एग्रीमेंट मिला, तो व्हाट स्विच 1 विल एज्यूम, माय नेबर इज रनिंग विद द पीवीएसटी, सो it will make an election according to the PVST on this particular segment. Clear?
Yeah.
Now, okay, this is done. But again, same concept happening in the CST as well, as nothing is different. Again, you cannot run the CST protocol. Same process. Okay, read this line, edge port. The edge port connect to the is a well-known Cisco spine tree users. It is a basically correspond to the port fast features, right? All ports directly connected to the end station. End station is what? Connected to the host. Cannot create a bridging loop in the network. Therefore, the edge port directly transition into the forwarding state and skip the listening and learning state. Neither edge port or port fast enable ports generate the topology change that we have seen that in the TCN. When the link toggles means what? Up down. And an edge port that receive a BPDU, right? Immediately what happened? It will lose the port fast status and become a normal spine tree port. At this point, there is a user configure value and operational value of the edge port state. The Cisco implementation maintain the port fast keyword we used for the edge port configuration. This makes a transition to the RSTP simpler over there. So on the edge port, what happened? We are not going to do anything. We just need to enable the port fast feature. That's it, nothing else. Because edge port will never generate the loop, because through the edge port, always we are going to connect with the end station. That is normally a server or PC. That's it. The link tab, we have a full duplex, and the shared is going to consider as a half duplex, right? Now, otherwise we have a point-to-point link. Point-to-point link is going to consider a full duplex. A port that operates in the full duplex is assumed a point-to-point, while half duplex port is considered as a shared by default. That's it, nothing else. Proposal agreement we have already seen, right? We don't need to enable the uplink fast feature over there because already everything is pre-configured. That's it. Any question in the RSTP?
So can we do load balancing in this
Of
RSTP?
course, buddy. RPVST, you can do that. RPVST, you can do that. RSTP is not, I don't think so RSTP you can do that because RSTP protocol is a not a PVST. The RSTP is behave like a CST like that. RPVST, you can do that. Cisco provided RPVST. Rapid PVST is a Cisco, right? And RSTP is like a common standard.
So if you want to do load balancing, we have to enable RPVST
But RPVST is a Cisco, right?
devices.
Then we have other concept like a MST. We can do the load balancing. In the if you have a standard device, right? Multi-bander.
Multi-band.
MST. We have MST option. It's fine. So we'll see that MST tomorrow, or see that today. Tell me.
Your wish. If we can complete by 10, we can go ahead. Then.
No, it will take some time. Maybe it will take the 1 hour plus. Okay, leave it the MST tomorrow. Then I'll show you the something more over there, right? In MST, and we'll cover this part as well as the one more thing is there. We call as a spanning tree security, right? So tomorrow we'll cover the MST and spanning tree security. So tomorrow we'll done with the MST spanning tree protocol. Okay, so Wednesday we'll do the DHCP part. All clear?
Yeah, fine.
Okay, perfect. Okay, guys. Have a great night, everyone. Bye bye.
Bye, love. Good night.